Hello all, welcome to software maintenance course. In this class, we are going to see what exactly is regression testing in software maintenance. So let us start first with regression testing. So regression testing basically is the execution of some set of test cases on a program to ensure that once the revision has been done, it does not produce any faults, it does not regress, it doesn't become less effective uh, than it has been in the past. So what we are trying to say here is let us assume that we have a product and the functionality of that product is to trigger confirmation, acceptance, and to dispatch emails when basically you click on confirm, accept, and dispatch button. Now let us assume due to some issues, the confirmation email needs to be fixed, and we have done few changes in the code which trigger confirmation which trigger confirmation thing when you click on confirmation button. Now in this case, when we are doing this regression testing or the testing thing, it does not mean we will only test confirmation email function. However, in this situation, we also need to see whether the acceptance or and the dispatch emails are not affected because of the changes that we have done in confirmation email function. So the thing is, you are modifying one function, and now because of this modification, you don't want the other functions not to work properly. So this exactly is regression testing. We are going to see this regression testing in more details in next lecture. Sorry, in next slide. So let's see what exactly is so regression testing overview. So it turns out that we can apply regression testing during development and in the field after the system has been upgraded or maintained in some or the other way. So it's not mandatory like you need to perform regression testing after the maintenance or some revision has been done in the product itself. But the thing is, you can always apply regression testing initially starting from the development process. So good regression tests give us confidence that we can change the object of test while maintaining its intended behavior. This is one of the main factor. Like we are going to get confidence once once the test cases once the product passes the intended regression test. So which means the behavior for which the product was designed, it is performing that task. So what exactly I'm trying to say here is basically this develop test release cycle will make us more clear exactly what exactly we mean to say here is. So basically this is it is a highly simplified process for we can say we have a program P which is referred in version 1. So basically in this figure, if you see, there are two different versions, version 1 and version 2, and they both represent the program P. So we can say the P, when we were using P initially, before using P, we have developed P. We have performed certain tests on uh, on on P, means the program P, and finally we have released the program P, which is now being used by the user. After a certain period of time, when P was in use, it may happen now user wants to add certain new features, or he may want to remove uh, some some errors which he found out during the usage of the product. And and this P dash, we are referring here P dash as the modified program. So in version 2, basically what we are going to do is we are going to modify P to P dash, and we are going to test this P dash for the new functionality which we have added in this particular modified program P dash. And of course, we are going to perform regression testing on P dash, so that which is going to make sure which will ensure that the code carried over the P behaves correctly. And finally, we are going to release P dash. So the thing is, the modified version which we are seeing here, P dash, it must needs to be tested for its new functionality. However, we can say making any modification to P, the developer might mistakenly add or remove uh, the code that causes the existing or unchanged functionality of P to stop working. So in this case, one has to perform regression testing, which you see which is there in step number 3 of version 2, to ensure that if there is any malfunction in the existing code, which it needs to be get detected, and before a release of P dash, it needs to be fixed, and it needs to be repaired. So this is the basic objective. So you have a version 1, you have developed some a program P. Now you need to change, or you need to add a certain functionality, but it may happen because of new functionality, some other functions are not working in the program P. So now P dash, now you want to ensure that, okay, so this P dash completely works, behaves correctly, and and in that case, we are going to perform regression testing on the modified P dash, just to make sure that the P dash works properly, and the functionality which we want, it is delivering that functionality. Okay, so we also have this activity diagram, which uh, initially we saw this develop, test, release cycle. We can also understand the same cycle activity which is going to take place during testing. If you see this figure 1, which is going this figure on your slide. Basically, this figure talks about the maintenance phase. That maintenance phase, once the software is being released for use. So this figure basically shows that after a software is released, uh, the failure report, or maybe some change request can come from the user, which is user feedback, and based on which the software is going to be modified to make those changes. So the main thing in this figure is there are two testing, if you see in this figure. The first one is resolution testing, and the second one is regression testing. So basically, the resolution tests are carried out to verify the code which we have modified. On the other hand, this regression testing is basically it is going to have those test cases which are going to be carried out on the unchanged part. For if you remember, in our previous example, we talked about we are going to make certain changes in the function which trigger confirmation. So the function trigger confirmation, the function in which we are making the changes over here in our example is trigger confirmation, which will come under resolution testing. However, the other functionality of our function, which was to accept, to dispatch, and to confirm, uh, to dispatch the emails, these two functionality will come. We need to test the functionality of these two functions also, which will come under regression testing. So after the testing is complete, the new version of the software is going to be released, and which again it will go with the same cycle. If you see last, new software version is being released, and then from release it will go back to user feedback. Then again, some change requirements are going to come because of some failure, or user wants to add new features, and this cycle will go on again and again. So let us discuss what exactly the steps are in regression testing.
So basically we will be given a program P, which will be originally tested with a test set T, and which is going to produce results R. And of course, because we are performing a software maintenance, we will also we are assuming that we are a software tester, regression test. We are going to perform. We are a software tester, and we are going to perform regression testing in this case. So the basic idea is with the program P, the original tested test cases we have, which is in test set T, which has produced results R. Now we also have a modified version of the program P, which we are calling it as our P dash. Now the first thing is we need to identify what are the changes we have done to the program P, and based on which we are going to select T dash, which is a subset of T, and on which we are going to re-execute this P dash, the modified program. Now, once you have re-executed P dash, the next step will be we have to test P dash with this T dash, and we have to reestablish correctness in P dash with respect to T dash. So basically, if you see here, we are going to select some subset of from T, and we are going to re-execute those subset on P dash, and we want to establish correctness of P dash with respect to this T dash. Now, again, this is something which you have used from the existing test T. However, as you have done certain changes in this in the function, now we also have to create new tests T dash dash, which we are referring it as T dash dash in our case as necessary. So you need to create this T dash dash, and this is the main thing, how you are going to create or how new test sets are going to be created. This is the main problem over here. So we are going to see this thing later. So the thing is we are going to create new tests T dash dash as necessary. And uh, so basically, we are going to also, on this, we are going to create a new test history, which is going to consist the results from executing. So the previously we had this results R. So from again with this new test case, we are going to create a new results history, and the T dash is basically it will be is the revised test history, and we may need to update expected results based on it. On the other hand, T dash dash is the newly expanded test history, and if we also assume that if the selection criteria is conservative, then T minus T dash is a part of the old test history, and which is still valid. However, on the other hand, there will be some test cases which will become obsolete, and in that case, we are not going to take those obsolete test cases. So I will give you an example also how exactly this test case is works in our later slides. So yeah, so the next thing is we are going to have three different types of regression testing. So I will not go into much detail about it because it is clear from the slide that when we are talking about unit regression, it talks about a certain unit means a certain function. So the clear definition is unit regression is done during the unit testing phase, and code is tested in isolation. So because you have just modified a particular unit and you don't have the entire system in which this unit is going to be integrated. So we are going to perform this regression testing on that unit. And that is any dependencies on the unit to be tested are blocked so that the unit can be tested individually without any discrepancy. Second is partial regression, which is done to verify that the code works fine even when the changes have been done in the code and that unit now has been integrated with the unchanged or already existing code. So now once you are done with the unit testing, then you are going to perform a partial regression in which where exactly where this code is being integrated. Now you have to see how it is going to work with the unchanged or already existing code. Now, once this once the unit has been integrated, now next step is to perform a complete regression
And complete regression here refers to is done when a change in the code is done on several modules. So now, if you have multiple modules, if you, for example, if you have multiple unit, if you have performed multiple unit testing, and if there and if you see there is an impact of a change in any other module, then you have to perform this complete regression. So the product as a whole is regressed to check for any changes because of the changed code. So this is a subset of task in a regression testing, which we are more interested in. So like we have discussed in the previous slide, we are going to have a program P, and also we have assumed that we are also going to have a modified program P dash, which is available for performing regression testing. Now, this modified P dash, which now we have because of some changes in the code, it is going to have a series of tasks that we need to perform. However, we have not shown the entire series of tasks that needs to be done on this P dash, but certainly we have shown the main steps that we need to follow. And the second thing is it is not necessary that you have to follow the same steps 1, 2, 3, 4, 4, 5, 6 in the same order, because when you are performing this regression testing, you're going to identify that in certain cases this like going with this steps in a sequence is beneficial. However, in certain scenarios, you may find that you don't have to follow exactly these steps. Uh, so so let's see what are the subset of tasks in a regression in testing. So the first step, if you see here in this figure, is test revalidation, selection, minimization, and of course prioritization. We are going to see these four different tasks separately. So what exactly this test revalidation is. So the thing is, when you have the test P dash, when you have this program P dash, we cannot say that we are going to test this program P dash against all test cases that we have developed prior with the program P. The reason might be because it we may argue that the test cases are not sufficient enough to be executed on it, or uh, it may happen due to one or more reason that the changes that we have done in the code, now the input data and the format which the P dash is looking for is not same which it used to take during the initial version P. So, and it may also happen that the inputs which we are specifying in some tests might remain valid for P dash, but the expected output might not. So yeah, so the test cases are valid, but the output it's not valid anymore. So in due to these different reasons, we perform test revalidation, and so basically, revalidation over here is refers to the task in which we check which tests for P exactly remains valid for P dash. So the basic goal over here of revalidation is to ensure that we are going to select only tests. We are going to use only tests that are applicable to P dash, and which will move forward to perform regression testing. So the next step is test selection. So once you have finalized which tests are valid, then you need to select exactly and the test cases. So now the thing is, the validated test which we have selected, it may be redundant, uh, or it may happen they do not
traverse the modified portion of P dash, which we exactly want to test. So the identification of test that is going to traverse the modified part of program P dash is normally called as test selection, and we also call it as a regression test selection problem. So RTS problem. However, the thing to note over here is this both next steps which are uh, both steps which are uh, uh, this minimization and prioritization are 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 techniques which are two different techniques which we are going to use for performing test selection. So regression test selection problem is we have multiple solution for regression test selection problem. We are going to see this thing later in our slides in more detail. So the next thing is test minimization. So we need to select a certain criteria based on which we are going to discard certain tests. For example, if you see on the screen, it says if T1 and T2 are test function of F in the original program P, then one might decide to discard T2 in favor of F1 because T1 and T2 both are the same function, are the test function F in F, and using both will might take a lot of time in our case. So the thing is, the main purpose of minimization is to reduce the number of tests to execute regression testing. So the next thing is test prioritization. So prioritization means we are referring to certain tasks which with the help of which we are going to prioritize tests based on certain criteria. So we say that a set of prioritized tests become useful when only a subset of tests can be executed to a resource constraint. And this test selection can be achieved by selecting a fewer tests from this prioritized list. However, there are multiple other test selection criteria which we are going to see in our later chapters or later slides. But this, uh, but the thing is, revalidation followed by selection, minimization, and prioritization is one possible sequence to execute this task. Like we just discussed this thing initially. So the next thing is once you have done revalidation, selection, minimization, and prioritization, you need to have you need to build a test setup. So test setup over here refers to the environment or the simulation environment or which the environment in which uh, you are going to simulate that particular modified program P dash. So this process can be very simple. You may just click on an application icon to launch the to launch the test sets, and it may happen like it is very it may turns out that it is a very complex process in which you need to set up the entire hardware and monitoring equipments to perform the test on certain application. And but the thing is, this testing setup becomes more challenging when you are working with some embedded software. For example, in the case of printers, cell phones, ATM machines, medical devices, and so on. We have taken an example over here of uh, of a pacemaker. For example, if if you want to simulate a heart, if you want to simulate a pacemaker, then you don't need this heart the exact heart of a human. You may have an environment, or you may simulate the working of a uh, this the simulator. You can have a simulator which is going to allow this pacemaker to be tested without moving this pacemaker or without installing this pacemaker inside a human. body. Okay, so the next thing is test sequencing. So that's like I said, the sequence in which the tests of an application are going to execute is being referred as test sequencing. However, it is going to vary from application to application, and it may not be a big concern when you are performing this regression testing. However, it becomes very important for an application which has certain internal state and which is in continuous running mode. For example, if you see this figure, it talks about a banking application in which the users have few functionality to perform. He can log in with the help of login mode, which we are referring it as LM. It can request. Then we have a request mode. However, the functionality over here is to deposit and to withdraw for those. So basically, there are three different functionality: login, deposit, withdraw. So LM, DM, WM. However, there are certain internal states, which is request mode and update mode, and these processes are continuously running. So in these cases, the order of sequence is very, very, very important. For example, let us assume that we this is the test input for all these three different modules. This test login module, test deposit module, and test withdraw module. We have this test case T1, T2, and T3. So now let us consider that these three test cases are designed to test this login, deposit, and withdraw features of our banking system. And we say we assume that we have a user ID is equal to 1, which begins with an account balance of 0, which is very important. So initially we have how we are going to test this module is we have started initially with account balance of 0. Now that this test T1 is going to check the login module and the exit feature. So if you see here in this diagram, we have the user is going to enter the ID in the login mode. It is going to, if it is a valid ID, then of course we are going to perform, or we are going to go to request mode, and user can perform certain functionality, and once he is done, he can exit. And if the user ID is wrong, he is going to stay in the same login mode. Yeah, but we also have assumed but seeing this test case, you may think these test cases are not enough to test the entire functionality of our banking application. But just to make you understand how exactly test sequencing is very important, we are just using this scenario. Now let us assume now this test T2 is how it works. You have the ID 1, then you request for doing the deposit. You enter the amount 50, and the expected outcome of the sequence is okay, welcome amount, welcome, and then it asks for the amount. You enter 50, then it says okay, the amount is done, and test deposit module works. Similarly, we have test T3, in which ID1 test, we have the same ID1, which requests to withdraw the amount, which asks to withdraw amount 30, and now which asks, which performs, which gives a request to withdraw, and then it gives the amount 30. So the expected output sequence is ID, okay, then we ID is correct, then it gets a welcome message, then it asks the amount, it enters, the user enters 30, then 30 is done, and the remaining amount is 20, which is updated in our database. And this is how this test withdraw module is executed. Now let us assume we want to modify this uh, test withdraw module as in such that there is no one can withdraw more than 300 euros in a single day. Now the question comes here is, do we need to test only? Do we need to perform regression testing in on 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 T3 because we have changed our condition? Like now we have given a restriction. You cannot withdraw more than 300 euros on a single day, or we need to follow certain sequence. Means we need to follow this order T1, T2, and T3. So you can think about it. What exactly you have to do? uh, Whether you can just run this regression test on T3, which is there, which is already there, or you need to perform uh, 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 you need to run a T2 or maybe T1 before executing T3. So it turns out that you cannot just do the changes in T3 because and you cannot just leave T1 and T2 because, for example, if you have done the changes like no person can withdraw more than 300 euros on a single day, and in T3, and if you put the amount over here, uh, let's say if you put the amount over here, for example, let's say 200 euros. So you will not get the same expected output over here because we don't have that amount in our balance. So it turns out that we need to execute this test T1, T2, T3 again in particular in the same order. So this is exactly what we need to understand is like sometimes it happens you may change one module, but it depends on the other two modules, and you need to change and you need to test the other modules, however, in a particular sequence in order to in order to ensure that the entire system is in it works correctly. So the next thing is test execution. So once the test sequencing has been done, you are going to execute the test. So this execution can be done by using some automated tools, and I have mentioned few automated tools. This is for you can just have a look how these automated tools exactly work. Avosure, Buckbuck, Time Shift X, Virtuoso, and Catalan. So these are a few test execution tools which is mostly used to perform regression testing. And finally, once you have executed the test, you need to verify the test. And this is also done automatically with the help of some text execution tool, which is going to compare the generated output with the expected output. However, as we discussed earlier, it may not be an easy process in embedded system because in embedded system often have some certain internal state, and of course we also have some hardware. Some hardware will be there which is going to control the software application. So in that case, you need to check all these parameters in uh, before giving OK to your program which you have modified. So now this is exactly what we have, regression test selection problem, RTS. And regression testing problem, if you see, basically it is like we are going to have a program P, for example, which comes from a version X, and that has been tested using a test set T against a certain specification. So in the diagram, we have P on the right-hand side, and we have the test case T, based on which this testing was initially done. Now let us assume that you have added certain functionality to P, or you have removed certain features from P because of user feedback. Now you have this modified program P dash, and now the behavior of this P dash should conform to the specification, to the new specification S dash. So earlier when this program P was released, we had the specification. Let us assume that we had an specification S. However, when we modified the program, now we want to make sure that the modified program P dash also conform to the specification S dash. And it may happen like the specification S and S dash could be same for P dash, uh, which is because of the results of modifying P or to remove false. And it can also happen that like this S dash could also be different from S in that S dash, which contains all features in S and few more. Because one of the features of S has been redefined as S dash. So the regression testing problem over here is to find a test set TR, which you see in the below circle. We need to find a test TR on which P dash is tested to ensure that the code that implements functionality carried over P also works here correctly. So if you see in this figure, this TR basically it is a subset of T, and which is going to be used for which was used for which we had used earlier for testing P. Moreover, this P dash must also be tested to ensure that if the newly feature that we have added also works correctly, and this can be done by developing certain new test cases which we are representing as new test as TD. So the basic objective here is the P dash is going to be tested against T dash, and T dash here is basically it is an union of TR, which is regression test, which and TD, the new test. And this regression test we have obtained from the previous test T. So where TR represent regression test and TD is the new development test suite which we have developed in order to verify the functionality of P dash. But over here, the one thing which we have to observe over here is we have divided test T in the first oval in the round shape into three different categories. The first one is TU, which represent redundant test, and the second is T not, which represents obsolete test, and the third is TR, which is represent regression tests. Initially P was executed against the entire T, this T test. However, P is executed only against the regression test TR, and of course against the newly developed test TD. So the tests in T that cause P to terminate or to enter into a finite loop might be included into this T naught or in TR, depending on the purpose. So in summary, the regression test selection problem is stated as we need to find the minimal of TR such that for all T that belongs to TR, T dash also belongs to TU, where TU is the test redundant test, and union TR, the regression test, for all which should be like this for the program which was tested on T, it should also be giving this it should give the same it should be equal, or it should give the same results for P dash on the same test T. Moreover, it should also be in the form such that P, the initial program P on this T dash should work. We can say it should be equal to P dash and T dash. So just to make it simple, the RTS problem is to find the minimal subset of TR of non-obsolete tests such from T, such that if P dash passes tests in TR, then it will also pass the test in TU. But the thing is to TU. However, the determination of TR requires that we know the set of obsolete tests T naught, which is obsolete, because obsolete tests are those which are no longer valid for P dash, maybe because of certain reasons. Now, in order to perform this regression test selection criteria for different programming paradigm, we have different approaches. For example, for procedural, we have a different approach. For object-oriented, we have different RTS. For component-based, we have different RTS techniques for database aspect and web application. So this is going to be your assignment. You need to check exactly what the RTS problem is for these different programming paradigms. And I have given the next assignment on the same thing, on which you need to find what are the different techniques available for these different programming paradigms. You need to compare them, and of course, you need to compare them on the basis of some merits and disadvantages. So these are the references which I have used for designing this slides. You can also refer these articles from internet. That's all. Thanks. See you in the next class.